Welcome. This is Cambridge 9709, May June 2022, paper 53, probability and statistics. So the first one, he is asking us to draw the cumulative frequency graph to illustrate the data. So we have to draw the cumulative frequency graph. So we have to make the scale over here. So for that, let me write it out over here. It is 0, 25, 50, 75, 100, 125, 150, 175, and 200. Over here, I take the scales of 20, 40, 60, 80, 100, 120, then 140, and 160 because the maximum is 150. Now, we are going to plot this one now. When it is 16, it is 25. 16, it is 25. When it is 25, it is 16. So 25, it is 16. So over here, when it is 50, it is 44. For 50, it is 44. Then for 75, it is 86. Third line, 86. Each line is 2. And for 100, it is 104. Each line is 2. That's why, because the gap is 20. So the gap is 10. And the gap is filled by 20. So 10 times 2 is 20. So each line indicates 2. And for 150, it is 132. 150, it is 132. And finally, for 200, it is 150. So draw a cumulative frequency graph curve over here. Next, use the graph to estimate the 20th percentile of the data. So he's asking us to find it out, the 20th percentile of the data. So what should I be doing it out? I have to use this cumulative frequency graph and draw from total frequency. How much is the total frequency? Is nothing but what? 150. So 150, 20 upon 100. So it's going to be 0, 0, 0, 0 gets cancelled, 30. So from 30, draw the line and drop it down. So it is almost all equals to what it says. This is 25 and 50. So this should be 37.5. After 37.5, so 12.5. The gap is going to be nothing but what? 12.5 divided with 5 parts. 12.5 divided into 5 parts. So each going point is going to be 2.5. So there are 2 lines after 37.5. So 37.5 plus 5, which is going to be 42.5. So you can write it as 43 or 42. Question number 2. 20 children were asked to estimate the height of a particular tree. Their estimates in meters were as follows. Find the mean of the estimated heights. So just add them all. 4.1 plus 4.2 plus 4.4 plus and so on. Add all and divided by 20. This is just a calculator based question. So therefore answer is 6.17. Find the median. Median is going to be the middle number. So there are 20 children. So 20 divided by 2 is what? 10. So 10th term and 11th terms average. So what is the 10th term and the 11th term? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10th term is 5.4, 11th term is 5.5. So 5.4 plus 5.5 divided by 2, which is going to be 5.45 meters. That's going to be the answer. Give a reason why the median is likely to be more suitable than the mean as a measure of the central tendency for this information, because mean is influenced by the extreme values, whereas median is not being influenced by the extreme values. So as mean is influenced by extreme values, the median will not change, the middle term will not change, even though if whatever is the highest number or the least number value has been changed by an extreme value. Question number 3. The random variable x takes the value minus 2, 1, 2, 3. Given that probability of x equals to kx square, where k is a constant, find the probability distribution table. So what are the values? Minus 2, 1, 2, and 3. Negative 2, 1, 2, and 3. X, probability of capital X equals to small x. Negative 2, 1, 2, 3. Plug in now. Plug in negative 2. So what does it becomes? 4k. Then 1k. Then again 4k. And again 9k. So we know that sum of all probabilities is going to be 1. Equals to 1. So 18k equals to 1, which gives me k equals to 1 upon 18. So what will be the table now? We can fill it out as, erase this one now and write it out over here. 4 upon 18, 1 upon 18, 4 upon 18, and 9 upon 18. That's going to be the answer. Find the expected value and the variance of x. For the expected value of x, negative 2 times 4 upon 18 plus 1 times 1 upon 18 plus 2 times 4 upon 18 plus 3 times 9 upon 18. Simplify that, you should be able to get that value as 1.56. Now coming to variance of x, minus 2 square times 4 upon 18 plus 1 square times 1 upon 18 plus 2 square times 4 upon 18 plus 3 square times 9 upon 18 minus 1.56 square. Simplify that, I am directly writing the answer 3.91. Question number 4. Ramesh throws an ordinary fair 6-sided die. Find the probability that he obtains a 4 for the first time and 8 on the 8th throw. So on his 8th throw, 4 for the first time in the 8th throw. So probability of getting a 4 is 1 upon 6. Probability of not getting a 4, so probability of success is 1 upon 6. Failure is 5 upon 6. So what is he doing it out? On the first time on his 8th throw. So therefore 1 upon 6 first time and remaining 7 times he is not getting it out. So 1 upon 6 times 5 upon 6 whole power 7, which is 0.0465. Find the probability that it takes more than 5 throws for Ramesh to obtain 4. So he is taking more than 5 throws. So probability of it takes no more than 5 throws. So x less than 6. So what am I going to do it at? One probability of x less than 6. How should I be able to do that? Which is 1 minus 5 upon 6 whole to the power of 5. Or if you don't want to do that one in that way, so less than 6 is first throw, then second throw, then third throw. Third throw means nothing but what? 2 throws he is not getting and the third throw he is getting. Then the fourth throw, 3 throws he is not getting and the fourth throw he is getting it out. Or fourth throws he is not getting it out and on the fifth throw he is getting it. So simplify that, that should be your answer, 0.598. Ramesh now repeatedly throws 2 ordinary fair 6-sided die at the same time. Each time he adds the 2 numbers that he obtains. From 10 randomly chosen throws of the 2 dice, find the probability that Ramesh obtains a total of less than 4 on at least 3 of 2 dice. So he should be getting it out a less than 4 on at least 3 of 2 dice. So we have to find it out the new probability of success and new probability of failure. So probability of less than 4. We have to get it out, probability of x less than 4. What is the probability of x less than 4? It can be either be 1, 2 or 3. Probability of getting 1 or 2 or 3. So 1 is not possible because he is throwing twice, right? It should be either 2 or 3. 2 is nothing but what? 1 and 1. 1 upon 6 and 1 upon 6. 3 is nothing but what? 1 2 or 2 1. So 1 upon 6 times 1 upon 6 and 1 upon 6 times 1 upon 6, which is going to be nothing but how much? 3 upon 36, which is 1 upon 12. So probability of success is 1 upon 12. Probability of failure will be nothing but what? 11 upon 12. Now I want at least 3 throws. At least 3. At least 3 means nothing but what? 1 minus probability of x equals to 0 plus probability of x equals to 1 plus probability of x equals to 2. So which is 1 minus 10c0, 1 upon 12 whole power 0, 11 upon 12 whole power 1 minus 10c1, 1 upon 12 whole power 1, 11 upon 12 whole power 9, minus 10c2, 1 upon 12 whole square, 11 upon 12 whole power 8. Simplify this, directly I am writing that answer. You should be getting 0.0445. That's the answer. Coming to question number 5. Farmer Jones grows apples. The weights in grams of the apples are grown are normally distributed with a mean 170 and standard deviation 25. Apples that weigh between 142 grams and 205 grams are sold to the supermarket. Find the probability that the apple grown by Farmer Jones this year are sold to the supermarket. So probability of X lies between 142. 142 is less than X less than 205. So always second one minus less than 205 minus probability of X less than 142. So probability of Z less than 205 minus 170 divided by 25 minus probability of Z less than 142 minus 170 divided by 25. So probability of Z less than 1.4 minus probability of Z less than negative 1.12. So probability of Z less than 1.4 minus 1 minus probability of Z less than 1.12. Negative to positive is 1 minus. Now 0.9192 from the table minus 1 plus 0.8686. Simplify that, 0.788 is going to be the answer. The next one. Farmer Jones sells the apples to the supermarket at $0.24 each. He sells apples that weigh more than 205 grams to a local shop at 0.30 each. He does not sell apples which is less than 142 grams. The total number of apples that he sells is 20,000. Calculate the total income for his supplies. So, what is he telling over here? He sells the apples which are greater than 205 grams at 0.30. So, first of all, find probability of x greater than 205. So, that is what is this? Greater than 205. Just now we were doing it out. It is greater than 205 is nothing but what? 9192. So, 1 minus probability of z less than 205, which is 1 minus 0.9192, which is nothing but what? 0.0808. Now he will be selling the one which is more than 205 for 0.30. So 0.808 0808 times 0.30 plus the other one to the supermarket is nothing but what? 0.24. What was the probability for the supermarket? We got 0.788. 0.788 times 0.24. But this is for 1. So for 20,000 times 20,000. Simplify that. You should be getting it out. 4,266.24. Next, Farmer Tan also grows apples. The weights in the grams of the apples follow the normal distribution. 72% are way more than W grams. So probability of X greater than W equals to 72%. So probability of Z greater than W minus 182 divided by 20 equals to 0.72. Convert greater to lesser than, Z less than W minus 182 upon 20 equals to 0.72. Then probability of Z less than W minus 182 upon 20 equals to 0.28. But 0.28 will not be there in the table. So therefore subtract from 1. So in order to nullify that effect, Z less than 182 minus W upon 20 equals to 0.72. So 182 minus W upon 20 equals to 0.583. So 182 minus W equals to 20 times 0.583. So W equals to 182 minus 20 times 0.583. Simplify that, you should be able to get that answer 170. Question number 6. Sajid is practicing for a long jump competition. He counts any jump that is longer than 6 meters as a success. On any day, the probability that he has a success on his first jump is 0.2. Success on a first jump is going to be 0.2. So failure is 0.8. For the subsequent jumps, the probability of success is 0.3. So after that one, success is going to be 0.3, 0.7. If the previous jump was a success, and 0.1 if it is otherwise. If at all it is a failure, it is going to be 0.1. Success, failure, it is 0.1 and 0.9. Shajid makes 3 jumps. So success, again success, success after success will be 0.3 and 0.7. But success after failure will be 0.1 and 0.9. Success after success will be 0.7 and 0.3 and 0.7. Success after failure will be 0.1 and 0.9. 3 jumps have been made. Draw the tree diagram. We have drawn the tree diagram. Then find the probability that Sajid has exactly one success, given that at least he has one success. At least one success. So success, failure, 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 success, failure, 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 success. This is nothing but what? Probability of one success. So what is it going to be? 0.2 times 0.7 times 0.9, which is 0.126. 0.8 times 0.1 times 0.7, which is 0.056. And 0.8 times 0.9 times 0.1, which is 0.072. So add them all. It's going to be one success is 0.254. This is probability of one success. Is that given that at least one success? Probability of at least one success. Probability of at least one success means nothing but what? Probable 1 minus probability of 0 success. So which is 1 minus 0.8 times 0.9 times 0.9, which is 0.352. So my final answer is going to be probability of one success by at least one success will be 0.254 divided by 0.352, which is 0.722. Next part, find the probability that he makes 6 jumps. Find the probability that only on his first 3 jumps are success or only last 3 jumps are success. So first 3 jumps are success, 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 or last 3 jumps are success. It can be like this, or success, 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 and a failure, failure, and a failure. So 3 success and last one. So if at all first one is success is 0.8, success followed by success is going to be nothing but what? 0.9. Success followed by success is going to be 0.9. Now the next one is going to be a failure. Failure is nothing but what? 0.1. Failure followed by a failure is 0.3. Failure followed by failure is 0.3. Now first one is failure is 0.2. Failure followed by a failure is 0.3. Failure followed by a failure is 0.3. But a success followed by a failure is nothing but what? 0.7. Success followed by a success is 0.9. Success followed by a success is 0.9. So it becomes 0.005832 plus 0.010206. Simplify that, 0.0160. Last question. Question number 7. A group of 15 friends visit an adventure park. The group consists of 4 families, Mr. and Mrs. Kenny and their 4 children, Mr. and Mrs. Lizzo and their 3 children, Mrs. Martin and her children and her child, Mr. and Mrs. Nanty. Then the group traveled to a park in 3 cars, one containing 6 people, one containing 5 people, one containing 4 people. The cars are driven by Mr. Lizzo, Mrs. Martin, and Mrs. Nantis, respectively. In how many different ways the remaining group be divided into 3 cars? So totally there are 15 people. So car number 1, car number 2, and car number 3. This one is done by Mr. Lizzo, Mrs. Martin, Mr. Nante. Now, car containing 6 people, one containing 5 people, and one containing 4 people. So this capacity is 6, 5, and 4. So already one person is there, so it can take 5 more, it can take 4 more, it can take 3 more. So out of 15, 3 people are already placed, 12. So I have to select it out of 12, 5 people, 12C, 5. So out of 12, 15 minus 3 is 12. Then again 12 minus 5 is nothing but what? 7. So I have to choose 4 people out of 7. Then again 3 are left over, 3C3. Simplify that one. It should be getting you the answer 27,720. The group enter the park by walking through a gate at one at a time. In how many different orders can the 15 friends go through the gate if Mr. Lizzo goes first and each family stays together? Mr. Lizzo is going first. Mr. Lizzo's family is nothing but how much? Mr. Lizzo is going first and there are total 3 children and Mrs. Lizzo. So 4 people. So for Mr. Lizzo, it is 4 factorial. Then we'll talk about the next family. Next family is Kenny's family. So how many people are there? Mr. and Mrs. Kenny plus 4 children, 6 people. So Kenny family will be nothing but what? 6 factorial. Then we'll talk about Martin. Martin family, Mrs. Martin and her child, only 2 people, so 2 factorial. And Nantes. Nantes is only those 2 people are there, so therefore it is 2 factorial. Times, we cannot change Mr. Lizzo, we can change only these 3 people, so therefore times 3 factorial. So finally my answer will be 414720. Mr. Lizzo will be always in the first, remaining 3 families can be arranged among themselves in 3 factorial. In the park, the group enters a competition which requires a team of 4 adults and 3 children. In how many ways can the team be chosen from the group of 15 so that 3 children are all from different families? So how many adults are there? So 1, 2, 3, 4, 5, 6, 7 adults are there. We have to choose 4 adults. So it can be done in 7C4. Now 3 children. And what is the condition for the 3 children? All 3 are from the different. So what am I going to do that one? 3 children are there and we have to select 3 children and all are from the different ones. So first of all I select from 4. So 4C1, one child is over. Next one I'll select from 3, 3C1, and this one is going to be 1C1. So 4C1 times 3C1 times 1C1. So it's going to be 420. Finally, part D, in how many ways can the team be chosen so that at least one Mr. Kenny and Mr. Lizzo is always included? Mr. Kenny or Mr. Lizzo, at least one is always included. So Kenny is included and Lizzo. So Kenny is included and Lizzo is not included. So basically there were 7 adults and children are nothing but what? 8. So we are taking Kenny. So out of 7 adults, 6 adults will be left over, but Lenny should not be included. So therefore 5 more adults will be left over. So 5C3. Why 5C3? Because one adult has already been selected. Times, for children there is no restriction, 8C3. Now if Lenny is included and Kenny is not included, it's going to be same 5C3 times 8C3. Finally, if both are included, so 2 adults are already included. Out of 7 adults, 2 adults are already taken away, 5, but 4 you have to select, already 2 are selected, so 5C2 times again 8C3. So this is going to be 560, this is going to be 560, this is going to be 560, so answer is 1680. That's going to be the answer. So that completes the paper. See you in the next paper. Bye.